All right, guys, welcome back. We are going to talk about the wiper signals now. Now, once again, in order to truly understand how to get the wipers to work, we have to understand the schematic. And this one is a bit of a doozy. So for the S197, it's a little more complicated. It makes adapting the S550 a little bit more complicated. I'm not going to say impossible because I've done it, but I'm going to have you guys bear with me as I go through the explanation of this installation. So here is the diagram for the S197 multifunction switch, specifically the wipers. Now, the way you need to interpret this is when you turn the dial, okay? When you turn the dial on the multifunction switch, what it actually does is it turns three, I'm going to call them dials for the sake of this conversation, but it turns three different dials in order to make different contacts with your, I believe, your smart junction box. And that allows the system to interpret different connections to be different. It allows you to utilize less wires for more functions. What do I mean by that? Well, let's say you have two wires, right? Or not two wires, let's say two light bulbs, and you want to signal to someone across the street four different issues you're having. With two light bulbs, you actually have the ability to signal four different ways. Okay? You could have no lights on, that's one signal. You could have your left light on and your right light off, that's one signal. You could have your left light off and your right light on. That's three signals. And you can have both lights on. That's four signals. So that is, in essence, how your wiper switch works in the S197. So you can see here, in its resting phase, when the wiper is not on anything, it's in the one position, you can see nothing is making contact here. Absolutely nothing. Okay? When we turn it to the first, or let's say the second setting, which is your intermittent number 1 speed, you're going to get to this one where your first dial is still grounded. Not grounded, it's open. Your second dial is open, but your third dial is closed. That means the system is going to interpret continuity from this positive source in pin 12 through to the exit of pin 15, which is your ground. That will initiate intermittent speed number 1. Okay, let's go to 2. Intermittent speed number 2, which is setting number 3, you have an open circuit on dial 1, you have a closed circuit on dial 2, and a closed circuit on dial 3. That means pin number 11 and pin number 12 have continuity. Okay, so you can see here that as we go through, we go to number 4, dial number 1 is open, dial number 3 is open, only dial number 2 is closed, which creates continuity on pin number 11. This is how your wiper switch gets away with having 8 functions while only utilizing, technically, these 4 active pins plus this ground pin. This pin is reserved. Pin number 10 is reserved for your washing. When you press it, that's what sprays. But that is how the system gets away with utilizing only 4 plus 1, 5 wires for 8 different functions. And technically, it could go even beyond that. So how do we make the S550 operate this way? Right? And you can see the rest of these are all mapped out here, so I'll let you guys go through that. How do we make the S550 work this way? Well, in order to do that, let's take a look at the S550 and see how it actually is set up. Now, once again, the S550 for the wipers is very similar to the turn signal in that everything is interpreted by the steering column control module. However, within the actual stalk itself, they are physical switches. You have your dial, which comes through a ribbon cable to the system. And then you have your pull in and your pull down, which allows the system to interpret your spray. sorry, your single wipe and your spray. So let's take a look at how this works, okay? So the way the S550 works is we'll start with the actual spray function, which I believe is over. This is actually a lot more complicated. So let's start with the spray. Here is your resting position. Notice my scratch marks don't go up to these pads. Very little, but that's really from when the stalk flips back up on its own. It scratches a little, doesn't really make continuity, but what I'm getting at is this stalk here is actually unused by the car because you physically can't actually pull the stalk up. It doesn't actually go up like the turn signal. It can only go down. So when you pull it down, it actually activates continuity between these two pins, and that is pin number 2 and pin number 7. Let me just make sure I got this right. Yes, because that's ground. Yep. Okay. Then what we have is your up and down, which is this one, which this gets a little more complicated. So if I'm looking at this, right here is my resting spot for my stalk. It doesn't make continuity with anything other than itself, which is our return. When you pull it down, you're activating the single wipe in the S550. That is here. That means you're activating this one, which goes to pin number 1. So pin number 1 will ground with this one, which is, once again, pin number 7. Okay? When you push it, we're going to skip pushing it up once, because I'll explain it in a second. We're going to push it up twice. When we push it up twice, that makes ground here, that makes continuity with this one, which, very similar to our S197, this is going to be our low speed, which goes through pin number 4. And then when we push it up twice, that's our high speed, which makes continuity with this one and this one over here, which is pin number 8. Now, the place where this gets complicated is very similar to our switches in the steering wheel of the S197, and I guess the S550, that utilizes the steering wheel, the steering column control module to interpret the different resistance values that depend on what dial you're set on. Now, the ribbon cable has 10 pins, that's down here, and each one of these pins technically corresponds to a different speed. 1, 2, and 3 are what are called your low speeds. This is speed number 1, speed number 2, and speed number 3. Pins 4, 5, and 6 correspond to your, what I like to call the high speeds. This is speed 4, speed 5, speed 6. And then finally, you have these unused pins here, which would go over to this, which is, I don't know, you call them super high speeds. It doesn't really matter because your dial in the S550 doesn't turn, 7, 8, and 9 clicks. It only does 6. So you don't even have to worry about these resistors over here. Basically, you would have this capacitor or a capacitor here, which would allow this contact to flow and complete the circuit. But because we don't have those, it doesn't really matter because the dial doesn't click that far. So the last pin here, pin number 10 in the ribbon cable, is your return, which functionally says, okay, when I am in my intermittent, which is here, I am going to need to have the feed come through. I'm going to need to allow it to go through the stalk. Depending on what dial you're switched to, it will allow the signal to follow through, and then it will go into the ground and be interpreted by the steering column control module. Now, I figured all this out using a multimeter, right? And just testing, okay, if I go here, which one of these has contact? Essentially what I did was I put it on setting 1, and then I held my multimeter here and here. Did I have continuity? Yes. Okay, turn it to 2. Do I still have continuity? No. Go to the next pin. Do I have continuity? Yes. And then I tested each pin just to double check to see if it was a multifunction pin similar to the S197, which indeed it's not. Each dial only corresponds to one particular ribbon coming out, which is good for us, right? That's actually really good. So how do we convert this into this digital signal, if you will? It's not really digital, right? But it's got these different resistance values into the S197, which is, you know, that multi-dial, different type of setup where you're activating more than one circuit at a time. How do we actually go about it? The first thing I was going to do was try to redesign the board, right? I was going to redesign the board, but what I found, and, you know, really I didn't research it, but what I was told was that having these gold-plated contacts, designing them is not difficult, but having them made at a manufacturer can be expensive. And oftentimes you need to buy these in sets of 5 or more. And what I found was that I really didn't want to do that, so I wanted to find a way to use the board the way I have it designed. So the first thing is we have to figure out, okay, how do we nix the resistance piece? Because the S197 doesn't even use that. That's step one. So we need to be able to get the signal off of this board without the resistances, just normal signals. And then once we have those normal signals, we need to find a way to actually map those signals to more than one more than one pin at a time, so that you end up with a circuit that is, when you turn the dial to a certain setting, you will be activating more than one of the connections. So how do we do that, right? What's the step? What do we do next? I've already mapped this out, so I'm going to take you guys through that in just a second. Sorry, I'm just working through something on my desk. Hold on one moment. Okay, so let's take a look at the solve that I've attempted to come up with. So what I determined is that we need to decide how are we going to map the functions of the new stock to the old stock, because the new stock has more functions but less wires. The new stock has a single wipe feature. The new stock has 6 speeds. So how are we? So do we want to have the speed? Do we want to have the single wipe feature? How do we do that? What I decided to do was, instead of having a single wipe, because quite frankly I don't even know how to activate that in the S197. I could probably momentarily activate the lowest speed and then let it turn off. I decided to just have the single wipe feature, which is pull down, act the same way as pulling in, which is the spray. So that's the first thing that I'm going to repurpose. I'm just going to make them both spray. Okay, pin number 3 is unused in the original schematic. Now, both cars have a low wiper speed. Both cars, we're going to skip over the speed settings. Both cars naturally have a ground. Okay, so here's my final function I decided on. And both cars have a high wiper speed function. Now that leaves us with this conundrum of the S197 has 5 speeds of intermittent. The S550 has 6 speeds, but those 6 speeds, because they work off of resistance, they only actually work off of 2 wires. So what are we going to do? Well, what I decided to do was I decided to do something similar to the S550, similar to the turn signals and the high beams, in that I'm going to replace this connector, but instead of only replacing it with an 8-pin connector, I'm going to replace it with a 10-pin JST connector. By replacing it with a 10-pin JST connector, I can actually utilize the unused pins, and I can separate them out into each one of my individual speeds so that the stalk sends out a separate connection for each and every one of my turn signals, each and every one of my wiper speeds to the car. And then I've mapped out what are each one of these dials, what pins does each one of these dials need to create continuity on, or essentially plug into on the C202 connector. So this is the final way I've set it up. In order to break the continuity for this, schematic, you're going to remove all of these 6 resistors, and you're going to remove this capacitor up here. This is going to make it so that your S550 stalk is going to send out 9 individual signals, each grounded with the 10. Sorry, not 10. I apologize. Each one of these is going to come out grounded through the 7 pin, which will ultimately be the only one that connects to your 15 pin in C202. Okay, so how are we going to do this? This is the direction for the solution. Single wipe will be converted to the spray function. Single wipe is pin number 1. Okay, that's right here. All we're going to do is we're going to send pin number 1 to pin number 10 in C202. You don't need to make any modifications on the board. Pin number 2 is your spray function. Same thing, we're not going to make any modifications. Why? Because the spray and the single wipe are not the dial which go through the ribbon cable. They are the up and down pull or the pull in. So they're both going to be rerouted to pin number 10, and we call it a day. The low wiper function, same thing. We're not going to modify it. We don't have to do any changes to the board. All we need to do is send that signal to pin number 12 from pin number 4. Okay, right here. Go to pin number 12, and we go to pin number 16. High wiper function, we're going to send from pin number 8 to 3 pins, 9, 12, and 16. The ground is going to go from pin 7 to pin 15. And then this is where things are going to get a little more complicated for the wiper speeds. Now, we have 6 technical wiper speeds in the S550, but we only have 5 wipe speeds in the S197. So what I opted to do was set the 1 dial to 0, because in my mind and muscle memory, when I turn my dial all the way down on the S197, that's going to turn it off. Well, in the S550, then, if I turn my dial all the way down, I can leave the stalk on intermittent, but if I have it all the way down on the 1 setting, it's going to be off. So I won't do anything with that on the ribbon cable. With speed number 2, I'm going to jump to number 3, which was an unused pin. 3 is going to jump to 5. 4 is going to jump to 6. 5 is going to jump to my new pin number 9. And then 6 is going to jump to pin number 10. Now, in practice, this JST connector stretches longer than the actual thing. So all you have to do is put a piece of Kapton tape over here, because there is a pad here which helped this connector, the original black connector, connect to the circuit board. You would put that Kapton tape on the board, and then you're only going to solder these 8 pins into the actual board, then solder the wires on, and that should be fine. Just make sure you don't burn through the Kapton tape when you solder it in. Okay? So what does this look like? Well, I mean, listen, it's a little bit messy here, but I'm going to explain to you what you see. First, when I removed that black connector, I accidentally pulled off a couple traces. I pulled off this trace, I pulled off this trace, and I pulled off this one over here. I actually tore them completely off the board. All you see with these red wires is these red wires are going to other parts of the board where I can reconnect those traces and repair them. What you're seeing here is me making these jumps. So number 1 doesn't go anywhere. Number 2 goes to pin number 3. Number 3 goes to pin number 1, 2, 3, 4, 5. Okay, and pin number 4 goes to 6. Pin number 6 goes over here to pin number 9, and then pin number 6 all over on the ribbon cable goes to pin number 10. And you can see, if I come back up here, the Kapton tape here that I put underneath this to isolate these last 2 pins from this big pad. Again, that allows us, and I actually put it all the way over here because I ripped this trace, so it really wasn't going to matter. You guys wouldn't want to do that if you don't rip this trace off. Long story short, this is going to put us in a position where we can have all of these individual wires coming out of the board. Here is that other trace that I ripped off. I'm connecting it over here. But this is going to allow you to have 10 individual wires coming out of this connector and completely bypassing the steering column control module. I put this piece of tape here not for isolation, but just to provide extra support to this JST connector, with the knowledge that for me, only 5 of these pins are technically holding this on because I ripped a couple of them off. For you, it would be 8, which is a little bit better, but it's still, you want to make sure that you have a decent amount of strength holding this down so that this connector doesn't get ripped off the board. Okay, so now that we have that, I'm going to switch over to the circuit diagram because it's a little bit more complicated than this. Because we have, and I'm going to zoom in here, because we have all of these wires and they all go into these connectors together, okay, you'll see that, for example, pin number 3 from my stock will go only into pin number 12. However, pin number 12 also goes into pin number 5. But pin number 5 also goes into pin number 11. If you were to set this up just strictly with those wires and just plug them right into C202, you're going to have a problem because each one of these connections is going to bridge to one another, and every one of these is going to be activated all the time. That doesn't help us. We need to find a way so that the circuit, if you activate number 3, doesn't actually also go through number 5 and go back down into number 11, which number 11 is also connected to brown, which is going to go this way and go back into 16. And once you activate 16, green is going to activate everything. So what we have to do is we actually have to put diodes in here. Each one of these diodes is essentially going to act as a one-way street for the circuit. So what will happen is if I activate each one of these, I can't come up here, get into this butt connector and go back down and go back over this. It's only going to allow the signal to flow in one direction. That's helpful for us, and it's really what's functionally needed. So the unfortunate part of this is that diodes are not necessarily easy to work with, and they're really complicated when it comes to putting them in an actual wire. I was hoping that we wouldn't need these, and these could just be a 10-pin JST connector here, and plug those suckers right into these pins, maybe use a couple butt connectors to split the signal and go straight into these, but it's not going to work that way. What we actually have to do is we actually have to get those diodes in. So I don't actually have a picture of this on the computer, but what I do have is a physical thing where I've created this. So what you see here is a board where each one of these diodes, you have your 10-pin JST connector. This is what's coming out of my stock. You see it here. Okay, all it is 10-pin mini 1mm JST connector here, 1mm pitch. I go into a 2.5mm, or sorry, a 25.4 millimeter, 2.54 millimeter pitch, just because it's easier to work with, and I've used these boards before. And all I'm doing is I put my diodes here, coming out of each one of these pins. Then I reroute it to each one of my individual 6-pin JST connector that's going to go in to my C202 connector. Okay, so it's very straightforward. It's not a heavy-duty amount of soldering. You can see here, it's just making sure that you keep track of how you solder everything. But it's going to be this little box here that will contain the one-way streets, if you will. And if I have the cover here, which is here, I've used these covers before. Once I cut these tabs out, my JST connectors will stick out the sides, but essentially I'll have this box that has that. It's going to be plug and play. I can remove it. I can unplug it. And that will basically allow me to have this steering wheel stalk set up where it will plug directly into my car. You can see it comes out here, and very similar to what I showed you guys the other day is if I set this up, I will have my steering column control module fully covered. This, I cut out a little notch over here so this sticks out, and you know, I'll have this set up where this will be the final functioning setup so that I could have the S550 stalks. The only reason I chose to go this route, guys, there's only one reason, and it's because to have the heated steering wheel, I want to use this S550 clock spring. The S550 clock spring only works in the S550 housing assembly, and in order to use the S550 housing assembly, I needed to get these stalks working. So, for those of you who are going to stop here, once again, at this point, all you would really have to do is plug this into your car, plug this into a voltage source. Doesn't need to be heavy duty. Probably could be 5 amps because it's not a heavy duty relay here. You know, get a power and a ground, and this whole setup will work for you. And that's it. Well, next up, we are going to start tackling the clock springs in order to get those set up for our heated steering wheel. But guys, I hope you learned something today, and I'll catch you in the next one. See ya.